Hello. In this video, I'm going to go over the overall approach to solving indeterminate torsional loading problems. Now, this approach is a four-step process, and it is very similar to the approach used when approaching indeterminate axial loading problems, in that the goal is to turn the problem into a determinate problem by solving for what the reaction in one of the clamps is. Let's say that you have a shaft that is clamped on both the left and the right end, and it has some torque applied to it. If you sum up the moments, you'll find that you only have one equation but two unknowns, where the two unknowns are the reaction in the two clamps. You cannot solve for this, therefore it's an indeterminate problem, and you're going to have to use this method in order to find what one of those reactionary loads in the clamps is. Once you have that, then you only have one unknown, and you can solve through the problem like it's a normal determinate problem. So first step is to remove the right clamp on the shaft, which turns it into a determinate problem. You then solve for the net twist at the right end, which would be net twist 1. So here's an example shaft. It's a shaft with varying segments of different geometry and materials with some loads applied to it. On the right end, the right clamp has been removed, and even though this shaft would take some work due to all the different segments, you would be able to solve from the right working towards the left clamp for each of these segments, finding the net twist. In step 2, you remove all of the different torques on the shaft as well as the right clamp. You then add a unit torque at the right end. With that unit torque, you then solve this determinate problem to find the net twist at the right end. This is net twist 2. So here's the same shaft with all the torques removed, and you can see that a unit torque has been added at the right end. It is counterclockwise due to the sign convention being that counterclockwise is positive, clockwise is negative. The unit torque is positive, so it's counterclockwise. You can then just solve through this problem working from the right towards the left as usual and find the net twist of all of the different segments. Once you have this net twist, then you can calculate what the reaction in the right clamp is in the actual problem. Now, there are two different cases possible here. The first case being, which is the most simple, where the right clamp has no amount of allowed slip or misalignment in it. From the very beginning, it is reacting completely. In this case, in order to find the force in the right clamp, the reaction, you just take the negative of the net twist 1 divided by net twist from step 2. And that will be in the base units of whatever you're working with, be it Newton meters or inch pounds or so on. As long as you stay consistent, it will work out. In the other case, there is an allowed amount of slip between this right clamp and the shaft. The shaft can twist a certain amount before this right clamp catches and applies a reactionary load. In this case, you need to check your net twist 1, the magnitude of it, whether if it is less than or greater than the allowed amount of slip. If it's less than, this means that the shaft isn't actually going to twist enough to even engage that right clamp. And so there is no reaction in the right clamp. You can ignore it, it's just not doing anything, and you can just solve as a standard determinate problem, which you basically already have because you've already solved for that net twist in step 1. However, if the magnitude of this net twist is greater than the allowed amount of slip, then this right clamp is producing a reactionary torque. In this case, use this equation down here, which is basically net twist 1 divided by its own magnitude times the magnitude of net twist 1 minus the slip divided by the net twist 2, and that overall is applied by a -1. This torque does follow standard sign convention, so if this value comes out negative, then you know it's a clockwise torque. If it's positive, then counterclockwise. Pay attention to this because just by looking at the original problem, you should be able to intuitively tell the direction that the clamps should react in order to counteract what the loads are doing. And so if you find that this force in the right clamp is going to act in the wrong direction, it's helping the torque instead of resisting it, then you know that something is wrong and you can double check yourself. But in the end, once you have found the reactionary torque in the right end, in the right clamp, then you can apply it to the problem, making it a determinate problem again. And this time you can just solve through it completely, just like you normally would for any other determinate problem. You can see here, now that we know the torque in the right end, you can apply it as, in the stead of the clamp, and you can solve through it like normal. So that's basically it. It's very similar to the same process with indeterminate axial loading problems. I'll be going over videos later that show me actually doing this, as well as working through a slip problem, misalignment problem, so that you can see how that works.